Yes, class. Good evening. Am I audible to all of you? Deborah, Fadil, Pia, Mariam.
Yes.
Okay. So yes, last part of this lesson now, class, before I start with the class, certain instructions for the upcoming classes. See, we have to rush up with the syllabus now. At least 2 to 3 lessons or 4 lessons should be completed. One thing I would request all of you is to share your date sheet with me on the WhatsApp group, because it becomes difficult to remember which all lessons are coming in whose paper, right? So if I'll have the PDFs with me of the date sheet or just the pictures of the date sheet, it will be easier for me also. All right. Fine. So yes, I was saying one thing that is for sure, share your date sheet with me. Second instruction that I want to give is regarding this specific batch, this batch only. See class, this is a new batch. We started from the scratch and everything we are doing it in detail. There isn't any single topic that we are leaving, right? We are doing as it is. That has to be covered for your syllabus. Problem that lies is right now class is that your half yearlies are coming, and see, if we go by the same speed, no, most probably till your second lesson or your initial of current electricity, it will be completed if we go by this speed. So now what to do? Firstly, we have to have extra classes. Now, as I have told you during your trial classes only, I have mentioned with each of you that you will be having extra classes because this is a new batch. So see, your all the days are fixed. I wanted to have a class with you all on Monday, but some of you are having other classes, some of you are having some classes, and rest of the weeks when you are all are available, I am having other batches classes. So Friday is the only day that is available when you also are not having any class and I am also not having any class, right? So for Friday, you people have your exam also on Friday. So we have to adjust one thing on Friday. 6:30 to 8 p.m. let's have, because 8 p.m. onwards you will be having your test. Morning you people have your test. And morning I am not available. It's not a working day. It's not a holiday. Friday is a working day for us in India. So Friday and Saturday, even Saturday and Sunday are usually the holidays that we have. Sunday is actually the holiday, but Friday is a complete working day, so I cannot have the classes in the morning. Otherwise, I would have taken your classes in the morning itself. So 6:30 to 8 p.m. we'll have to have a class. All right. One thing. I hope, please just keep on interrupting me in between. I hope the second point is also clear to you. First was sharing your date sheet on the WhatsApp group, so I have an idea. Then don't tell me that this lesson was also coming and I did not consider it. Please, because it becomes difficult to remember. No, because other students are also there. 11th class students are also there. NEET students are also there. JEE students are also there. So just share your syllabus on the group. Try to share it today only, because according to that, I'll plan the classes. If I want, I'll take some of the classes quickly. We'll have more classes in 1 week, right? So second thing is regarding Friday, 6:30 to 8 p.m. means IST. Now, according to your countries, please convert Dubai ones and Saudi ones, and whichever is the difference. If it's 6:30, then KSA timing is 4 p.m., right? And 5 p.m. would be for the UAE people, right? I think this is the what is the scenario currently. So please be available on Friday, at least till your half yearly. These are not throughout. You won't be having extra classes throughout. Even I don't want to take extra classes throughout. It's just that at least for your half yearlies, you all should be prepared, right? Thirdly, this class duration also has to be increased, because 1.5 hour class in the evening, that is not sufficient on Friday, and 1.5 hour classes that we are having on Saturdays and Sundays. So today you are having normal 1.5 hour class the way I take, after which you will have your after class assessment. But after today, that is from tomorrow onwards, whichever classes you are having with me, apart from Friday, because I wanted to have a 2 hour class on Friday also, but Friday you people have your exams usually. If you are not having, then I'll take a 2 hours class on Friday. Otherwise, your class duration is increased to 2 hours. Then only we'll be able to cover lots of syllabus. Clear? All the instructions are clear to all of you? No queries? Deborah, fine?
Yes, ma'am.
Mariam, Fia, clear?
Yes, ma'am.
Okay. Coming back to our lesson, let us quickly complete this lesson. See, we require Gaussian surface. I had told you what was Gauss theorem. Gauss theorem is the electric flux means the number of field lines that are crossing surface area normally. So electric field lines which are passing through an area perpendicularly, we call them, we give a term as electric flux. So electric flux, this is proportional to the charge enclosed. So we have a formula that is the electric flux enclosed within the surface is 1 over epsilon naught times the charge that is enclosed, right? This is what we have studied. Now, how to select the Gaussian surfaces? There are certain systems in which certain Gaussian surfaces are fixed. Gaussian surface is basically a hypothetical surface that we draw to make our system and surrounding, to differentiate between system and surrounding. Suppose I give you a wire. Wire is open, any external force can occur. But Gauss theorem, I told you that this is valid only for closed surfaces. So if the surfaces aren't closed, we make the surfaces closed. How do we make the surface closed? We make a hypothetical Gaussian surface. And we'll be having a radius of that Gaussian surface. Radius of the sphere would be different. Length of the wire would be different, right? But a Gaussian surface would go parallel with it. So see, random Gaussian surfaces also you can draw. For example, a point is there or a rough figure is there. You can draw irregular boundaries to emphasize on the Gaussian surface. That's fine. But certain figures are there that are part of your syllabus, and as it is, it comes in your exam. You just have to remember the steps. Even you don't need to learn all the derivation steps. And in derivations, you people also must have experienced this only. What I feel is that up sphere. This we did in the last class, this part. Yeah, na? What I was saying. I was saying, see, in the derivations, the problem that comes is what you people also must have experienced, what I have also experienced is that the first line, we are not able, if we just remember the first line as it is, right? If we remember the first line as it is, then entire derivation we are able to manage. It's the first line that, you know, haunts us, that what was the first line, then you will be able to derive it. So please do one thing. I will suggest all of you that take separate page, take a separate register or take separate pages and just mention the heading. Where are all the derivations written? What you have, what are you continuously studying? Mention the heading and just the first line at least. Best way is that if you can have a separate notebook for derivations, that's the best thing. If you can do that, make a separate register, all the formulas on one sheet for that lesson. For example, electric charges and field. Write down all the formulas in one page. Then from the second page, write down all the derivations. Just do not elaborate it so much. Make it concise and write it. Then second lesson, then the formula, then the derivation. At the end, right now, this won't be so helpful for you because you have to in any ways go through every point. But towards the end of your session, when you will be revising for your board exams, that time scrolling in between these is not helpful. You have to have separate. I'll share the formulas with you, but derivations I won't be able to share. You have to have the derivation separate with you. Formulas and derivation, because you also know, if you know the formula, 50% of question is solved. If you know the derivations, you will get long questions, marks easily, 5 marks, 6 marks derivations are always present. So do these two things at least. That's for your benefit. Now, for example, if we have a wire, so certain derivations are fixed, which we have to follow, and that as it is, they come. If you have a wire, we draw a cylinder as the Gaussian surface. If a sphere is present, we draw a sphere only. If a disk is there, so we draw a circle. So certain Gaussian surfaces are fixed. Now, this was a wire. This is a wire. So I have drawn a Gaussian circle. This is infinitely long wire. Infinitely long wire means the extents are extending up to plus infinity to minus infinity. You can extend it, extend it, extend it, extend it. It won't stop ever. Now, to find out the solution, what we did, we took 3 cases. One was this part, the curved surface of the cylinder. How does the cylinder look like? See, suppose this is a cylinder. So for a cylinder, you are having this curved surface, and this flat surface, and this entire curved surface is placed. So we have three surfaces for cylinder. This one end, flat circle, this flat end, circle, and this rolling part, that is the curved surface. Okay. So now we'll be solving each parts differently. First part, when we drop the area, electric field lines are moving, let's say, towards the right. When we drop the area vector in the first part and the third part, it's making 90 degree. So one thing be clear, this is ES cos 90 degree. 0, 3 is also ES cos 90 degree, which is 0. Now the second part that is left, only we have to solve this. Because this is ES cos 0 degree, so that will become ES. All right. Now, what is the surface area, curved surface area of a cylinder? Curved surface area is 2 pi r L. Now, we have to differentiate between the radius and length. Right now, there is one radius only, that is the radius of the Gaussian surface or the cylinder. Fine, this r is the radius. Now, let us put the value. So, flux second will be E 2 pi r L. Here is the value of flux. Now, according to Gauss theorem, what is flux? Flux is Q by epsilon naught. Lambda we specially did this topic in the last class because I told you this is going to be used over here. That is your linear charge density. Linear charge density is charge per unit length. So from here, charge I can write as lambda into length. Put in the value here. Flux becomes lambda length by epsilon naught. This is one value you have. Let's equate both the values. This is one value. See, this is one equation. This is second equation. When you equate both of them, that was 2 pi r L. This is lambda Q by epsilon naught. No, not lambda, wait. Lambda L by epsilon. Length will be cancelled. Electric field also there. So electric field becomes lambda by 2 pi r epsilon naught. This is the formula for electric field. So electric field is inversely proportional to r for a infinitely straight long wire. And among electric field and radius, this is inversely proportional to each other. Fine, this is what you have to remember. Note it down quickly, then we will see for plane sheet. Okay, next is when you have infinitely plane sheet. So for plane sheet, what we do, if we have, suppose this is the sheet. If this is the sheet, so what we do, this is infinitely plane sheet. It means this is extending from infinity to, means from 0 to infinity, upwards also and downwards also. So you cannot choose a Gaussian surface that is covering it entirely. So we drill a cylinder over here. It's like this is the surface that is facing. So I'll take a cylindrical surface here, and this cylindrical surface will be here like this. Like this way, I'll choose a cylindrical surface. Got it? So this is what has been found. So again, if we have a cylinder, 3 curved surface areas of cylinder will be present, first, second, and third. Now here, electric field lines for the second will be 0 this time, because this is 0 this time. So this is ES cos 90 degree, which is 0. Coming to E1, see, net flux is what? Net flux is E1 plus E3. 2 is 0. E1 plus E3. So see, this becomes ES plus ES, right? Cos 0 degree is 1. That becomes 2 ES. This is the value of flux. What is the value of phi from Gauss theorem? This is from your Gauss theorem, right? So let's equate both of these, Q by epsilon naught to ES. Okay, one more thing. Let's we'll have we won't have linear charge density over here. This is in 2D, so we'll have superficial charge per unit surface area. So charge will be sigma into surface area. So phi will become sigma surface area by epsilon naught. Now again you have two equations. This is the first equation. This is the second equation. Equate both of these. So 2ES is equal to sigma S by epsilon naught. S gets cancelled. Electric field becomes sigma by 2 epsilon naught. So electric field is independent of the radius this time. Electric field versus radius, this is completely independent of it. All right. Now, one thing, class, that comes as a question is, see, suppose these are 2 sheets given. Now what will you do? So there are 3 surfaces. There are 3 points in which you will get questions. Either it can be, see, 2 sheets are there. 1 sheet I have talked about. Simple formula is equal to sigma by 2 epsilon naught. No confusion over there. See, suppose we are having 2 sheets. These are the 2 sheets present. So 1 point can be here, right? 1 point can be in between these 2 sheets, exactly here. And 1 point can again be here. This is what we have studied. Now, when we are talking about how to calculate the net electric field in these cases, so if this is positive, this is negative, see, any case can come to you. We have to just understand it so that in any case, you will be able to apply everything. Coming to the first point, when the point lies here. So see, for positive part, field lines will be away, E1. For negative part, field lines will be towards. This is away, this is towards. Clear? So net electric field is E1 plus E2. This is how we write. So net electric field will become E1 is sigma by 2 epsilon naught minus I cap, plus E2 is sigma by epsilon naught plus I cap. Like this, you will have to write it. Like this, you have to write it. Second point, see, because of this positive sheet, it will move away. So E2. Because of this negative sheet, it will move towards it. So E1 plus E2 when we'll do. Now, how will you choose the direction of the resultant? Sigma by 2 epsilon naught. Both will be I cap. This will also be I cap, sigma by 2 epsilon naught. Just class, one more thing. This is 1, 2. This is 1. This is 2. If they were same, then we would have directly added them. This I'm doing just a generalized case. Here also, E final will be E1 plus E2. So E final is E1 is towards the right, that is sigma by 2 epsilon naught. Right is plus I cap plus sigma by 2 epsilon naught minus I cap. Now this is a very generalized manner I have done, very generalized. Now you will be getting values also. It can happen you can get as it is also. If you are having values, then you have to substitute, use proper vector addition. Whether when minus is used, you will have to subtract. When plus is used, you will have to add. So proper vectors you have to consider. So this is just a gist I'm telling you. Questions can be modified. It can happen both are positive. If both are positive, then here both will be in the same direction. Answers minus sign will be shifted. Clear? Spheres we'll do, but quickly note this down. Electric field is not proportional to radius in this graph. See, do you see any radius over here? So if it is independent, that's how the graph will look like. Clear? See, electric field due to different types of spheres. So we have hollow spheres, we have solid spheres. Among hollow, we have conducting and non-conducting, and solid conducting is only there in your syllabus. Solid, non-conducting, this is not there. Now, see, spheres are there in your syllabus. Yes, one thing, good. Difference between conducting and non-conducting. Conducting means the sphere is present and the charges are residing on the surface of the sphere. The charges are not going inside the sphere. Non-conducting, the charge is going to the volume of the sphere. The charges are present within the sphere. All right, so these are the three types of sphere. Now, when the electric field, first case, let us discuss. Now, when these three cases, let us discuss. When electric field is outside, when the point is lying outside. So see, Gaussian surface, I've told you it will be a sphere. Surface area, we'll take it as 4 pi r square. Now, why we have to discuss this is, see class, there are two radius now. There are two radii now. One is the radius of the sphere and one is the radius of Gaussian surface. All right. So when we talk about surface area, we take the surface area of the Gaussian surface. So 4 pi small r square. We are taking the area of the Gaussian surface. So 4 pi small r square. Clear? That's why capital R square is not included. Now, when you are equating E is equal to 4 pi r square, Q by epsilon naught is equal to Q divided by 4 pi r square. Now, one more thing, some modifications which you can do. Again, you can take surface. Again, you can take surface charge density. So, sigma is equal to charge per unit area. Area is 4 pi r square. Now, you will take. Sigma is what? Sigma is surface charge density, means charge per unit area of the object. Charge per unit area of the object, that is sigma. That's why we are taking capital R here. But in our calculation of Gauss theorem, we take the Gaussian surface. So radius was small r for the Gaussian surface. This difference has to be clear. If this difference is clear, then nothing difficult is there left in this question. Now just substitute the value of Q. Q becomes 4 pi capital R square. So, yes, I can repeat. See, sigma is surface charge density. Surface charge density means charge per unit area of the object, area of the sphere, not area of the Gaussian surface. So what is the radius? What is the area of this sphere? 4 pi capital R square, that is the surface area. But when we were talking about this small r here, we chose small r, not capital R. Why? Because according to Gauss law, Gaussian surface's area we consider here. Clear? That's why small r square and here capital R square. Now this will be cancelled. E is equal to sigma 4 pi r square by 4 pi small r square epsilon. 4 pi will be cancelled. Electric field is sigma capital R square divided by small r square epsilon naught. Second thing, if point is lying exactly on the surface. See, now your Gaussian surface and now your sphere, both are having the same radius. When the point is lying on the surface, sphere is also this, Gaussian surface is also this. When the point was lying outside, this was the point. So we constructed the Gaussian surface like this outside. When the point is lying exactly on the surface, so Gaussian surface will also be this and the sphere will also be this. So what's the difference that was coming? No, here 4 pi small r square. Now this becomes 4 pi capital R square only. So this becomes, this is, Q is 4 pi R square by epsilon naught. Now equating it with E 4 pi capital R square is equal to sigma 4 pi capital R square by epsilon naught. 4 pi R square cancelled. Electric field is sigma by epsilon naught. And inside a conducting surface, no charge is present. So directly electric field is 0. Now this is the graph. See, first formula. When it was lying outside, Or let's go from inside. Electric field is 0. So from 0 towards the surface, that is inside part, electric field is 0. Exactly on the surface, the value is sigma by epsilon naught. Then it is inversely proportional to radius. Remember, E is equal to sigma capital R square by epsilon naught small r square. So E is inversely proportional to R square. So outside, this is inversely proportional. Fine, this is the theory of the spheres. Note it down from you. And wherever you people are getting stuck, please ask me. Text me in the chat column or unmute yourself. Text me, it's better because I think the speakers aren't working very well. So just text me. Yes, Deborah, what's the issue with the timings? Please let me know. After 6:30, you people have your exam. 6:30 to 8, if I take the class, then after 8 p.m. you people have your exam. Ji? Yes, Deborah, please let me know. You have texted and you're not responding further. Others can leave. Tomorrow we'll have a 2-hour class. You have CLAT coaching before 6. So before 6 you're having? No. I'll take the class from 6:30. Tomorrow we'll continue. Mariam and Fia, you people can leave. Deborah, please tell me the timing. Mariam, you saying something?